the major diameter D is the largest diameter of the screw thread, and the minor diameter D1 is the smallest diameter of the screw thread, and the pitch diameter D2 is the diameter where the width of the screw and the glue is equal, and the thread pitch P is the actual distance of corresponding points on adjacent thread, and the lead S. The lead S is the actual distance of the mating thread where at once in one revolution. For single thread, N equals P equals S, and the lead angle push is the angle between the perpendicular of axial and the right of the thread, and the value of push can calculate use this expression, and included angle alpha. Alpha is the angle between two flanks of the thread alpha, and flank angle beta is half of the alpha, and the contact height H. H is the distance between the major diameter and the minor diameter H. So the thread can form like this. There is a right triangle with angle C, the lead angle, and the right triangle wrap around the cylinder to form the thread. Okay. These the types of screw thread according to the type of tools and the direction of rotation, number of helical lines, and the position, function, and shape of body of revolution. And this is the type of tools of screw thread. The square thread, and for this thread, the angle R is 0 degree, and the triangle thread with a R of 60 degree, and a trapezoid thread with a alpha of 30 degree, and a buttress thread with a alpha of 33 degree, and the flank angle beta is 3 degree for the this blank, and this blank is subject to operating load. Okay. This is the blank angles and self-locking efficiency about the 4 types screw threads, and the efficiency for a triangle screw thread is the worst. So this is a joint screw thread, and square trapeting and butters is driving screw thread. Okay, this is the condition of self-locking. When the angle of pushing is less than angle rule, the angle rule is uptake F. F is the friction coefficient, and rho is equivalent friction angle. When pushing is less than rho, the screw thread will self-lock. Okay. And this is the left-hand thread, and this is the right-hand thread. And this is a single start thread. This is a double start thread and triple start thread. For single start thread, the needle L equals P, and for double start thread, the needle L equals 2 times P, and for this condition, the needle L equals 3 times P. Okay. This is the single start thread, and this is the triple start thread. Okay. Okay. According to the position of thread, there is an internal thread and external thread. Internal thread is the thread on a large or hole, and external thread is the thread on a screw. Okay. The coarse thread is used most widely, and fine thread have better capability of resisting loosening. So these are the types of the ordinary screw thread, means the triangle thread, and the parallel screw thread, taper screw thread is joint screw thread, and the square screw thread, trapezium screw thread, and butters screw thread is driven screw thread. And the trapezium screw thread is used for bidirectional loads, and this is for unidirectional loading. Okay. Okay, this is the basic types of screw thread joint. The bolted joint is a bolt insert into the hole and tightened by a nut. This is the ordinary bolted joint. Between the bolt sink and the hole, there is a clearance, and like this. this is the rammed power bolt, and there is no clearings. Like this. When the bolt joint subject to a load F, for the ordinary bolted joint like this, for the load, okay, there is the bolt will be stretched, and the clamping members are compressed. Okay, and there is a friction between the joint and the clamping members. Friction. F, friction. But for the rammed power bolt, there is no clearance. Okay, so we are subject to shear strength and bearing stress between the bolt and the hole. Okay. This is the ordinary bolted joint, and this is the rammed bolt joint. Okay. And both the ordinary and the rammed bolted joints used to join the members, the same members, using Cyrus hole. And for one joint, the member thickness member, we use screw joint and stud joint. This is a screw joint, and it's a screw inset into the hole and the threaded hole. And for the stud joint is the bolt joint to the member permanently, and the mating member and can remove the nut and the washer. So this can assembly frequently, and this is joint permanently. If we move the screw and the threaded hole will be well. Okay. Like this. The two joint can be disassembled frequently by moving the nut and the washer without damaging the threaded member, and the screw joint cannot be disassembled frequently. And this is the set screw joint is designed to be inserted into a threaded hole to bear directly on the mating element, like this. And not used in vibration applications. Okay. And this is the standard screw thread fasteners, like bolt, stud. For example, in stud joint, use this stud, and screw. Special screw thread joint, nut, and washer. Okay. When the jointed member jointed, we always insert the bolt into the hole and twist the nut. And we cord a preload, a pre-force. And for the bolt, the bolt is being stretched, so it's subject to a tension stress. And for the connected members, be compressed and subject to a compression stress. Okay, and this is the preload. And the preload is lot more than the 18% of the material's limit of yielding, sigma s. For carbon steel bolt, usually choose selection the QP, the preload, is less than 0.6 to 0.7 sigma s times A1. A1 is the error. And for alloy steel bolt, the preload is less than 0.5 to 0.6 sigma s times A1. And A1 is the error of minimal life section, and A1 equals pi times D1 square and over 4. So the preload is difficult to measure. So we always to measure the tightening torque and then to calculate the preload. When the bolt is subject to a torque T, and T is equals T1 plus T2, and T1 and T2 are the friction of the bolt and the members respectively. Okay. And this is T1 and this is the T2. T1 is the friction of the bolt and T2 is the friction of the members. Okay, and we can calculate and simplify the equation and obtain that the tightening torque equals 0.2 FA times D. FA is preload. So we can use this equation to calculate the preload. And this is the control measures of per-tightening force. Using the measuring torque spanners or fixed torque spanners, or we can measure the equilibrium of the bolt. And this is the initial length, and this is the length when the tightening with a preload. So the bolt can stretch, and we can calculate the tightening force. Okay. This is the loosen pretension. When the connected members with preload, but they will lost the preload gradually under wearing or vibration, and so the large and the large will twist, and the connected members will separated. Okay, and we call this loosen. And the function of loosening is preventing. We can use a spring washer like this, or oxide vertical large like this. And also use block large like this. And this is to increase the friction to prevent loosen. And or we can use special elements like quarter pin. The pin inserted to the holes, and clamping washer like this, or this. And for several clamping steel wire. Or we can use permanent method, for example, using punch beam. Or limb. Okay, two components are to be connected by bolt. One of components is relatively thin, and the connection is disassembled frequently. Which of the following is the best choice? Bolt joint, a snap joint, a screw joint, or set screw joint? We choose which, and the relatively one of the components relatively thin and should be disassembled frequently. We use which? joints, bolt joints is used to connect members, same members, okay, with several hole, okay, to connect the same members with the several hole is bolt joint, and we can use the ordinary bolt joint, and the ordinary bolt joint there is a clearance between the bolt and the holes, and we also can use round bolt joints, and there is low clearance between the bolt and the hole, okay, and this is to connect same members, and for sink members we can use stud joint or screw joint, okay. For example, the sink is member, and we can use a stud and screw joint. And the stud joint is you can use a bolt connect the members, and we can use a nut, okay. And we can disassemble by moving the nut. And the screw joint is the joint connect the members permanent. Okay, connect permanent. So we choose the B. And for the stud joint, this joint had a nut, and the nut can be moved. And the screw joint is permanently connect the members. Okay. And we have better capability of resisting losing from vibration because of the smaller lead angle. Okay. The square thread is used to driving force, okay, and for the we always use ordinary screw thread to joint members, and the lead angle lead angle and for the fine thread and color thread different because this is coarse thread, and this is a fine thread. And we can calculate the angle Cauchy 10 L over like this. L is the lead, okay? L is the lead, and the lead is the actual distance the mating thread will advance in one revolution. And for the fine thread, the L is small, and for the coarse thread, the L is large. And the self-locking condition is Cauchy less than rho. Okay, the rho is equivalent fraction angle. Okay, Cauchy is due at 10 F, and F is the friction coefficient. So for fine thread, the self-locking is good. So we choose A. Okay. And the double large is usually used for A, increasing stress, B, increasing stiffness, C, prevent losing. A, B, C, which the function of double large. Double large, too large.
Prevent losing this. Prevent losing this.
We choose C.
Yes.
Okay, C. Preventing loosening, because double large can increase the friction. Okay. And the available method to restrain a nut from become loose on a bolt is 1. Increase the axial force on the threaded connection. B. Increasing stiffness. C. Preventing relative rotation of screw tail. If we increasing the axial force on the thread connect, the members will separate it. So to restrain a nut from becoming loose on a bolt. C. Preventing relative rotation of screw tail. Okay. And in this part, we'll calculate the strength of screw joint. The main failure forms for bolt bearing tensile stress. The bolt bearing tensile stress. The main failure force is deformation, plastic deformation or elastic deformation, and vertical fracture is subject to a variable load. And bolt bearing shear stress, the main failure forms are shearing or cracks. And we usually use ordinary bolt joint for tensile stress, and use Raymond bolt joint for shear stress. Okay. And the condition of loose bolt joint. So the loose bolt joint, there is low preload, without preload. For example, without preload, so the stress, we can calculate the stress, and it's subject to actual stress Fa. Okay, so the stress is force over the error. Okay, and the force is Fa, and the error is
pi square.
Fa times,
Pi square, yeah.
and the D is the minor diameter of the screw thread. The smallest diameter. Okay. So the stress condition can be expressed as Fa over pi times d1 square over 4 is less than allowable stress. D1 is the minor diameter. Okay. So when under this condition, the bolt joint without preload, when we design, we should choose a screw thread with the minor diameter D1 larger than that. Okay? And this is the design formula. When the bolt joint without preload. Okay. This is the stress calculation of tightened bolt joint. And under this condition, before the bolt carrying the operating stress, there is a preload on the bolt. Okay. The tightened bolt joint only bearing rotating force, and the tightened bolt bearing axial load, or tightened bolt bearing shearing force. There is the 3 conditions. And 1, the strength of tightened bolt joint only bearing pre-tightening force, only bearing the preload. And in this condition, bolts bearings direction of axial tensile load F0 and friction torque T1. T1 is the friction between the bolt, and T2 is the friction of the members. So the tensile stress is Fa is Fa over the error, and should less than allowable stress. And for torsion shear tau 1, use tau 1 can calculate like this, and can simplify the equations, and we use the third strength theory. We can obtain the sigma Ca. Sigma Ca is 1.3 times Fa, and over pi times d1 square, and over 4 should less than allowable stress. And this is the condition only bearing preload, and the sigma Ca should less the allowable stress, and we can use this equation to calculate the sigma Ca. Okay. And while bearing transverse working load, the friction on the joint face generation by protecting load F1 should more than transverse load F. And the protecting F1 should less than this. And C is reliability constant. Usually, the value is usually 1.1 to 1.3, and M is the number of joint face, and for example, the M is 2, and F is the friction coefficient. And if F is 0.15 and C is 1.2, M is 1, then we can calculate F0 should less than 8F. F is the transverse working load. So this is for the ordinary bolted joint, and for the ordinary bolted joint, it's the preload F should be very large. Okay, because the F1 should larger than this. Okay, so under transverse working load, we usually choose rimmed bolted joint. Because for ordinary bolted joint, we usually use friction to prevent the transverse working load. Okay, use friction. But use a rimmed bolted joint is for the ordinary bolt like this. We already have. We usually use the friction to prevent the transverse load. But for a rimmed, the bolt and unlike the member, there is no clearance, so it's subject to a steering stress of the bolt, and this bearing stress between the bolt and the members. So if the operate work is transverse, we usually use the rigged bolt joint, because under this condition, use friction to prevent the transverse F. The preload should be very large. Okay. We can use key sleeve pin to bear transverse load, or we can use ringed whole bolt and then have no clearings. This is for the transverse load. And under this condition, the intensity of tightened bolt bearing axial load of ordinary bolt. Okay, have a rest.
Yeah.
Okay. For example, this is the looseness state. This is the looseness state, and when the preload is carried, this is the preload state, and when the bolt is subject to a preload QP. The QP is caused by the tightening torque, and on the tightening torque, the large twist, and the bolt is subject to a tensile stress, and the members is subject to a compressed stress. This is the copy. And under the tensile stress, the bolt will stressed by a deflection of lambda B. We are stressed in like this, okay? And this is the initial length, and this is the length after the preload, okay? And the members will be compressed with a deflection of lambda m. Okay, so this is the compress. Okay, so when the bolt is subject to a axial force F, axial force F. Okay, F is calculated by the equation P, the pressure P times A, and over Z. Z is the number of the bolt. Okay, and under this axial force, the bolt will strength further. Okay, will strength further, and with delta lambda b. Okay? Okay, and under this force, the members under preload is compressed, and under this force, the members will be released, okay, or relaxed, and it will stand in this with a racing delta lambda m. Okay, so the length change of bolt is the initial bolt L and plus the lambda E and plus the delta lambda B. This deflection is caused by preload, and this is caused by the actual force. Okay? Okay? And the thickness of the member is minus lambda m and plus delta lambda m. Okay? Okay? Okay, this is the length of our so let's see. After tightening after adding the preload, elongation of bolt is lambda b0 there. Okay, and shortening of joint members is lambda m0 there. Okay, and after loading F, there is a filter deflection, and the total elongation of bolt is delta lambda plus lambda b0. Okay, and the shortening of the members is lambda m0 minus delta lambda. Okay, and the remnant preload decrease to F1. This is the preload, and this is the rammed preload, and F1 is less than the preload F0. Okay, and the total tensile force F2 equals F plus F1. Okay, let's see. First deformation, and this is the force, and this is the preload F0. Okay, and this is the deflection of bolt under preload is lambda b0. And this is the deflection of members is lambda m0. Okay. This is the preload, and this line is for the bolt. This line is for the members, and this is the information. And this is the elongation of bolt under preload. This is the comparison of members under preload. Okay, because the preload causes tensile stress on the bolt and compressive stress on the members. Okay, then we added an axial force F. Under this F, the elongation of the bolt is lambda delta. It's delta lambda. There, and this is the force of the bolt. This is the force of the members. Okay, because under the axial force, the bolt will suggest further, and the members is relaxed. And this is the resultant force F2. Okay, this is the resultant force F2, and this is the axial force. F0 is the preload, and F1 is the remnant preload. Okay, so we have F2 equals F0 plus delta FB equals F0 and F2 equals F plus F1, the remainder preload, and we can calculate the value of delta lambda, and then we can calculate the resultant force F2 and the remnant preload F1. And F2 equals F0. F0 is the preload. Okay, F0 is preload. F is the axial force. Okay, F is axial force, and the CB is the stiffness of the bolt. Cm is the stiffness of the members. And this is the relative stiffness coefficient. And the remnant F1 equals F0 minus F times this. Okay. This is the relative stiffness coefficient. This is without the value. Okay. And under the condition, tighten the bolt bearing shearing force. And on this condition, we usually use Raymond bolt. Okay. We also can calculate the stress sigma P equals F, the shearing force, over the rho times L V. L V is the, okay, and should less than sigma P allowable stress. And condition is tau is should less than the allowable shear stress. Okay. Should the L, when design the L, the minimal L should larger than 1.25 D0. Okay, and this is the condition under shearing force, and it's for rimmed or bolt. And this is the condition of a combined preload and variable axial load. For static stress, sigma CA can calculate use this equation. Okay, and when design, the D1 should larger than this. Okay, this is the this condition is for the tightening bolt only bearing tightening force. Okay. So under the free force, the sigma A should satisfy this, and under variable stress, the working stress cycled from 0 to F. F is this, and the total tensile load carried by each bolt cycled from QP. When the working stress is 0, so it's the preload, and to F2. F2 is F plus the rammed preload. Okay, and we can calculate the maximum stress. Use this. Q is F2, and the minimal stress is this, and we can calculate the stress amplitude. Use this, and we can calculate the safety factor SCA, and the SCA should larger than the allowable S, and the sigma minus 1 TC is the endurance stress of the bolt under completely reversed stress. Okay, sigma minus 1. And when the bolt is in this error, it's safe. Example, a hydro cylinder with an inner diameter of D is 160 millimeter, and oil pressure P is 1, and connected by 8 uniformly distributed bolts. 8 bolts, and the relative stiffness of the bolt connection is 0.3, and the preload is 2.5 F. F is the operating force. The operating force. Okay, and the allowable stress is sigma is 120, and then beside one, the total tensile load carried by each bolt, and two, the resultant load on the clamped members. Three, the minimum diameter required for the bolt. Okay, it's the condition of the combination of a preload and actual force. Okay, this condition. Okay, under this condition. So first we calculate the total tensile stress, tensile load carried by each bolt, and this is the F, and this is the deformation, and this is for the preload copy. Okay, this is copy, and after the F, and this is the F, the actual force. And we should calculate the total tensile load carried by each bolt. Is calculate this force, the resultant force of the bolt, and calculate the resultant load on the clamped members. Is there. This is the Raymond preload. Okay, we calculate this F2 and this F1. Okay, calculate. We can use the equation. Okay, for the from the equation F2 equals F0 is QP, right? Plus F times CB plus CM, and this is the relative stiffness coefficient, and F1 equals QP minus F. Okay. So we calculate the total tensile load carried by each bolt. Total tensile load carried by each bolt. So first we calculate the external load is shared by each bolt. Okay. The pressure P is 1. Okay, and the force force F, we can calculate the force F equals P times A and divide the number of the bolt. Okay? So this is the P. P is 1. And this is the error. And this is the number. Calculate the F is this. Okay? And we load this and this. Okay? This and this. And we load the relative stiffness is 0.3. Okay, this is 0.3, and we load QP. QP is 2.5 F. So F2 is 2.5 F plus 0.3 F. Okay, equals 2.8 F. And the F is, we calculate F is this. Okay, so the total tensile load carried by each bolt is this. Calculate. Okay, and then we calculate the resultant load of the members F1. Okay, F1 is the remnant preload, and F1 is QP minus this times F. QP is 2.5 F, and this is 1 minus 0.3 is, okay, and we can calculate, this is the resultant load on the members. Use this. The Km is the Kb is the Cb, the stiffness of the bolt. Okay, and Cm is the Km, is the stiffness of the members. Okay. Okay, calculate the QP, and then we calculate the minor diameter required for the bolt. Okay. We use this sigma, calculate the external load shared by each bolt is, we use this equation. Okay, P is 2 megapascal, and A, we can calculate A, and the number is 6. Okay, so calculate the external load shared by each bolt. This is the external load shared by each bolt, F. Okay, calculate the F. and P is
P is
2 megapascal, okay?
2A.
And A is A,
We have to find out
You
A.
have to find it.
okay. Like this, we load the P,
P.
the fluid pressure P, okay?
Yeah.
P, and P is F over A, okay? Show F is P times A, okay?
Yes.
For this F, this F,
We understand.
F, okay? F, and this, the error is P times pi times D cubic and divide
4.
4, okay? Pi is,
Pi r square.
so we can calculate the pi is
3.1416.
okay, and D is 150, okay, and divide 4 times 6, okay? Okay, so the error is the external, it's in the inner, okay, this is,
This is 5890.5.
okay, we can calculate the answer is
5890. Yes, 5890.5.
okay, this is the answer. So we know the error is there, okay. This is the fluid press, okay. Calculate the force F. So we load the F, the external axial force, okay, on each bolt, and the resultant force of the bolt F2 is F minus F1, okay. F1 is the resultant force of the members, okay. So this is the external load, not the resultant load of the bolt.
Easy bolt.
Okay. Use this. Okay. Okay. The preload code P is 8,000. The operating strength of bolt F is 4,000. So we load the F. Okay. And the stiffness of bolt and clamp members this respectively. So calculate the external load is shared by each bolt.
Okay, tell us the loss.
Force under the axial force, the bolt strength, but the members released. The members released, and the force of the members will decrease. Okay, from QP to F1. F1 is the remnant preload. Okay, so F2 equals F plus F1, and we can use this equation to calculate the F2, okay? And calculate the resultant load on the clamped members. So calculate the F1, okay? Calculate the F1. Use the equation F1 equals QP minus
QB
1 minus the relative stiffness coefficient KB plus KN F. Okay. So calculate the resultant load on the connected members. So QP is
8,000.
1000
8,000.
minus
8,000.
this is
8.
this is
Oh,
4
sorry.
and the relative is 2.2, so this is 2.8 times F. F is 4.
7201. 7201.
Yes, and this is
7201. Full answer.
7.
7201.
Fourth is 4,000. 4,000 times 0.8. 3200. So is 4. Okay. This is 4,000. Okay.
Yes.
Okay. And calculate the resultant load on the members F1. So the two equations are to use to calculate the resultant load of bolt and members. Under this is under the condition the ordinary bolt is subject to the combination of preload and axial force. Okay, under this condition we use this, and then okay. So have a rest.
Yes, no, sir.
Okay. Low preload and low friction between the bolt and the members. Okay. And the FA is tensile stress. And for tightened bolt joint, we have conditions of only preload. Okay, there is only preload, and the preload can cause the elongation of the bolt. So there is a tensile stress on the bolt. Okay, on the bolt, and the tensile stress should express as FA times the FA is preload. Okay, for this condition, without preload, the FA is operating stress. And for this, the FA is preload because the bolt only subject to the preload. And this should should less than the allowable stress. And D1 is the Miller diameter, the smallest diameter of the screw thread. This is, and the tightened torque also can cause shear stress. Okay, also can cause a shear stress. T1 minus T1 is the torque or the friction. T1 is the friction of the bolt under the preload. Okay, under preload or under the torque. So we can obtain for this condition, sigma Ca is 1.3 Qp. Qp is the preload and divide should less than the allowable stress. And this is for the condition only subject to the preload. Okay, we also have conditions subject to a combination of preload and axial force. Okay, axial force. And under this condition, we can calculate the resultant force of the bolt. F2 is QP plus CB plus CM times F. F is the external axial force. And we can calculate the resultant force of the members. QP minus we can calculate we can use these two equations to calculate the resultant force on the bolt and on the members. So for the bolt, we can obtain that sigma Ca equals 1.3. So the F is F2. Okay, F2 is the resultant force of the bolt, and times should less than allowable stress. We also can obtain the sigma for the members, but the error is different. This is for bolt, this is for the members. Okay, and we also have a condition is preload variable force. Okay, when the axial force F variable, and under this condition we can calculate the maximum stress is 2, and the minimal stress is QP. QP is the preload. Then in this condition, the variable force is 0. The variable force varies from 0 to F. Okay, and the force of the bolt varies from QP, the preload, to F2. Okay, F2 is the maximum stress. Okay, this is the variation of the bolt from QP to F2. So the minimal stress is QP divided, and we also can calculate the sigma A. F is the maximum force. Okay, this F, there is QP, and there is F2, and we can calculate the SCA. SCA use which condition? We start the fluctuation stress under fluctuation stress. The bolt should wear vertical. Okay, vertical. And this condition is for the sigma mean is constant. This condition, okay? Then because the mean is 0 for the bolt, the mean is QP. And for this condition, we can calculate the SCA is should less than the allowable safety factor. Okay, and this is for this condition we can obtain this, because the for this and the condition, the failure mode will be deformation. Okay, plastic deformation or elastic deformation or fracture. And for this condition is vertical. So we use this equation. Okay, and for this subject to shear bearing or transverse force, and we also can obtain the how is F should less than the allowable shear stress. Okay, we can should less than 1.5 Li D0. D0 is the diameter of the hole. Okay, is the diameter of the hole. This is the ringed bolt joint, and this is for this condition to subject to shear ring stress. Okay, and the ordinary bolt is for this condition to subject to tensile stress. Okay, and the D1 is the minor diameter of the screw. The minor diameter of the screw is this. Okay, because for the ordinary diameter, this is the screw. Okay, and there is low screw with maybe low screw, and there is a clearance between the bolt and the core. Okay, and there is low clearance between the bolt shank and the core. So under this surface, okay, in this surface, he was subject to bearing, okay, and the bolt theory, okay, and L meaning is this length, because this length is the minimal length, and this length should less than 1.25 is 0 when design the remained bolt. We should let this minimal length less than this. Okay, and this is for the remained bolt under shearing stress, and this is the ordinary bolt for tensile stress, and this is the without preload. This is with preload, and this is only preload. This preload plus extra F. F is static, and this is preload plus variable stress F. If in this condition we use this equation to design, and this condition we use this to calculate the sigma Ca, and the sigma Ca should less than allowable sigma. And for this, we use this condition, and then the F is F2 for bolt. The F2 is the resultant force of the bolt, and for this condition we use this. Okay, this is the strength of the bolt. Okay. The resultant force of the bolt is QP plus this. Okay, this is the calculation equations for the resultant force of bolt, and this is the equation for the Raymond preload, or the resultant force of the members. Use this calculation, and in this condition, N and QP is this, and the operator strength and stiffness is this, and flow in the prayer is cycled from 0 to 4,000. The error of minimal life section A is 96.6. Calculate sigma A and sigma N. And this is condition on the board is subject to preload and fluctuating stress. And the fluctuating stress it varies from 0 to 4,000. Okay, calculate sigma A and sigma N. And we can use the equation. This, okay, sigma A is this times this. Okay? So calculate this. Okay, and we load the is QT plus the and sigma max is F2 plus okay. So we can calculate the CA. We lose the CB and CM. Okay, this is CB or KB, and this is KM or CM is the stiffness. Okay, stiffness of the board and stiffness of the members, and F is the pressure cycle from 0 to 4,000, and for the fluctuating stress, the actual stress is from 0 to F. So we know F is the maximum this value 4,000. Okay, and we should know this. Okay, and calculate the CA, and we should calculate the C and the mean stress. Okay, so use this to calculate the CA is CB 4 times plus times 2 okay. So how to calculate this? How to calculate this? We know the error, section errors,
96.6 millimeters.
and the section error A
Pi r square.
is pi
R square.
L
Yes,
over
this is 4.
4. Okay, so we calculate calculate this is 4 times 8, okay? And calculate this is 2
By
times 4 times okay, and this, and this, and this, or this, 10, okay, is equals times right?
this much.
So calculate is 4 point what?
4.14.
4.115.
15. Yeah, 15.
125 and 15.
It's 15 is
This?
yes, yes.
Oh, okay. And this is the sigma A, and it's stress amplitude. So then we should calculate sigma M, the mean stress. Sigma M. How to calculate sigma M? How to calculate sigma M? There is
Equation.
low equation for the sigma M. So how to calculate sigma M? The mean stress we started before. The mean stress, how to calculate the mean stress? The mean stress sigma M equals sigma max plus sigma mean. Okay, so we shall calculate sigma max and sigma minimum. Okay, and we know the QP, right? QP is 8,000, but we don't know
F2.
F2. But we calculate F2 before.
Yes, QP plus KB.
Yes,
Yes, much. Yes.
this is the F2,
F2.
right? F2 is
8,600.
okay, and we can calculate this or this and calculate the sigma M, or we know the sigma A and we calculate the minimum stress, and use this and this we can calculate mean stress. Okay, because the sigma A is minus sigma minimum over 2. Okay, use sigma A and sigma minimum, we can calculate this. Okay, so calculate the mean stress is calculate the mean stress. We can calculate the sigma mean. Okay, this is the sigma A. Okay, and we can calculate the sigma minimum. We know QP. We know this. This is
And
8 times
4.
4. Okay. This is, and we can calculate the minimum stress is 18.2.81.
81.
Okay, and then we can calculate the sigma max. Sigma max is 2 sigma A plus sigma minimum is 91.11, and then we calculate sigma M is 86.96. Okay, calculate the. And then we also can calculate the safety factor SCA. We calculate this. Alright. Use the equation. Use this equation we started before. For sigma minimal is constant. We use this, yes, to calculate the SCA, and the SCA should larger than the allowable S. And this is for this sigma minus 1 should change to sigma minus 1, should change to sigma minus 1. This is for the board, okay? This is for the board. So we can use this condition, or use this, okay? Use this equation to calculate the SCA. And this is the stress of the board. We have several conditions to calculate the stress of the board. Okay. And this is the table of the safety factor S. And this is for M6 to M16. Okay. This is the diameter and pitch dimension of core thread, and this is for the core thread, and this is for the fine thread. And M24 means the regular course thread. 24 is the nominal diameter, also the major diameter of the screw thread, the major diameter, okay? And 24, we can find 24. And in this 4A coarse thread, we can know the pitch. P is 3. And for fine thread, M22 times 1.5, and this is the express of the screw thread. And M is screw is an ordinary screw thread, and the number 22 or 12 is means the major diameter D of the screw thread, and the symbol X, and 1.5. This means the pitch P of the thread. From this table, we can select the standard screw thread, and for example, M12 means the the major diameter is 12 and the pitch is 1.5 and it's a fine thread. Okay, and this is for the right-handed screw, and for left screw we should put this L edge like this. For example, M24. This means left-handed screw thread, and the major diameter is this, and pitch is this. From strength calculation, we can calculate this. For example, we can for the condition, the bolt only subject to preload. Okay, for this condition, we can calculate sigma CA equals QP should less than allowable stress. Okay, and we can obtain the D should less than yes, so D1 should less than this. Okay, and this allowable stress is determined, and the preload is determined. So we calculate the D1. Okay, we calculate the D1, and under this condition, D1 should less than 10. Then we can use this paper to select the ordinary screw thread. For example, this is the value of minor diameter. If the width less than 10, so we can choose this. Okay, this screw thread. And this is for the ordinary screw thread. And this is for the trapezium screw thread. We also can know the pitch and edge and the major diameter and the pitch diameter and the minor diameter. Okay, this all is the standard screw thread. Okay. And from this paper, we can load the S. But this is for the remnant bolt, and this is for the ordinary bolt. It's bearing tensile stress, and this is for the bolt without preload. And this is the static action axial force, and this is for the fluctuating stress. We can choose the value of S. The S is the allowable stress. So we can calculate the SCA should less than the allowable stress. Okay. And this is the structure design of screw bolt joint. Okay. For the bolt used in glue, and the basic principle is the geometric shape of joint face is usually designed to be simple axial symmetry during shape, and this rectangle and this or triangle like this. Ensure loading uniformly on each bolt. Okay, and for rammed bolt joint, don't lay more than 8 bolts in line in parallel with the direction of the vice load. This is for the rammed bolt. And when bolt joint vary bending moment or torque, the location of bolt should near the edge of joint surface. This is reasonable and this is unreasonable. Okay. And when bearing extra load and transverse load in the same time, the part resistance here should be adopted to endure transverse load. And this should have space for spanner. This. And this, the angle should less than 60 degree. And for such important joint as pressure, space between bolt, there should be less than value recommended by the table. Okay. This is the working pressure. When the working pressure is less than 1.6 megapascal, and the T0 should be 7D. Okay. D is the diameter of the bolt. The number of bolts distributing on the same cycle is usually choose 4, 6, 8, even number. Okay. And the material diameter and length of bolts in the C group should be uniform. To avoid bolt bearing additional bending load, or this, the surface is not smooth. Okay. We can use this, and the surface incline. Okay. We use the washer. Okay. Load and dimensions of the for the bolt glue, and the material diameter length and the protecting node of all bolts should be same, and the symmetry center of bolt glue and the center of finger or joint surface are matched together, and the joint surface remains plain after loading. This For example, this is the joint of bolt glue bearing transverse load. This is the transverse load, and there is 1, 2, 3, 4 bolts. And for rim and bolt, the working stress load of each bolt is F is over Z. Z is the number of the bolt. And for ordinary bolt joint, so this is the maximum of stress generated between joint surface after per load must more than or equal to transverse load. So there is this. This is the friction. Okay, Z is the number of bolt, and we can calculate Ks is the skate preventation coefficient, and Ks is 1.1 to 1.3. And under bearing transverse load, this is for the Raymond bolt joint, and this is for the ordinary bolt joint. Okay. Because the ordinary bolt joint is the maximum friction should less than the transverse load, and joint glue bearing torque like this condition, and it is to a common or ordinary bolt depends on the friction generating between joint surface to resist the torque T. So we have this, and R is the distance. Okay, R is the distance between there to the bolt. And this is the centroid, and the bolt distance. So we can calculate the F0. And for Raymond bolt, it depends on action of shear ring and bearing to resist the torque T. So we have Fi equals K times Ri. Ri is the distance. So Fi over Ri is constant. So we can calculate the maximum force with this. And this is for the bolt glue bearing axial load. We have calculated this condition. Okay, F is F epsilon over Z. Z is the number of the bolt. Okay, and if rotating load is the total load of each F2 is F2 is not equal to F1 plus F. F2 equals to F1. F1 is the Raymond preload, not the preload, because the members should be relaxed. Okay. It's not F1, not the preload. It's the Raymond preload plus F. We have calculate. Okay. Calculate. Use the equation F2 minus Q, the preload plus CB times CN times F. Use this equation. Okay. Not equals to this is not. Okay. And the joint of group bearing upsetting moment like this. There is an upsetting moment M. Okay. Like this condition we also can find in the left the board should be strength filter. Okay. This filter and this compress. And on this condition, the members will be relaxed. Okay, and on this condition, the members will be compressed filter and the bolt will be relaxed. Okay. Like this. Okay, under this condition, the resultant force on the bolt will increase and the compress on the members will decrease. And in the right, the resultant force on the bolt will decrease and the compression on the members will increase. Okay. Condition. And we can calculate like this. R is the distance. Calculate total gain. Okay. We also can use this curve to describe. And B1 and B1 C1 is for the left bolt. The left bolt will move to B1. Okay. On the right, will move to B2. Okay. B2. This is the resultant force for the left bolt, and this is the resultant force for the right bolt. And the C1 is the resultant force for the left member, and the C2 is the resultant force for the right member. Okay, we can calculate this under this condition. And we can calculate the sigma P max and the sigma P minimums. Okay, under this condition. And this is a allowable extrusion stress of material of joint surface. This is for the steel, cast iron, and wood brick, and so on. And total tensile force of bolt can use this. F0 is the preload and this is the F max. Okay. And materials and allowable stress of bolt And materials for screw thread joint usually use this steel. Q215 steel or 35 or 45 carbon steel. And for the condition under impact or vibration stress, we will use alloy steel. Okay. And washer. Okay. The capability grade of a bolt divided into 10 levels. And 3.6. 3 means the tensile stress is 300. 4.6 means the tensile stress is 500.
500.
Okay, and the number 6 means 6 times 3 is 18. Okay, it's 18 means the sigma s is 180, and this means the
24.
stress is
24.
114, and this means the sigma stress is
500.
300.
Yes, yes.
So this is the symbol
18.
and this. So the 6.8 means the
48 and 480.
the tensile stress is 600 and the yield stress is 418. So we calculate this. Okay, we can calculate the sigma CA, and we can choose a standard for the tensile stress and yield stress. We also can calculate the diameter. So we can use the table to choose the standard screw thread, coarse thread or fine thread. We also can choose the P and the major diameter. Okay. And this is the capability grade of large. It's divided into 7 levels. And this can this is the grade of large, and this is the grade of the bolt. So for the grade 4, the large, we can use the bolt of this grade. This is the grade of the bolt. This is the grade of the large. Okay. Carmen used about 4.8 grade bolt is usually choose this. Okay. Okay, so okay, class is over.
Okay.